So today's lesson, we're going to deal with area and perimeter of irregular figures. So the first example is Serena's garden is a rectangle joined with a semicircle as shown in the diagram below. Line segment AB is the diameter of the semicircle. Serena wants to put a fence around her garden. So calculate the length of the fence that Serena needs to the nearest tenth of a foot. Well, understanding that we're trying to find the fence to go around her garden, she really needs to calculate the perimeter of this garden. So essentially, she's going to have to calculate the straightaway, the straightaway, the straightaway, and then this curved portion. We don't need to go through the garden for the fence. It's just around the garden. So hopefully that you realize that the straightaways, 9 feet on the left side, means there's also 9 feet on the right side. The fact that line segment DC is 6 feet, so is the diameter of AB. So the idea is we need to know that for the perimeter, first we need to know what 9 plus 6 plus 9 plus this part of your circle. And that's basically a semicircle. So let's deal with the semicircle for right now. In terms of a semicircle, the circumference of a circle is pi times the diameter. But we need to realize that we need to divide it by 2 because once again we're dealing with a semicircle. We know, and maybe I should probably get you back up to the screen, is your diameter happens to be 6. So I know that I'm dealing with 6 pi divided by 2 or just 3 pi. So 3 pi is what's going to be replaced in here. So in terms of what I need to do, I'm going to do 9 plus 6 plus 9, okay, which is going to be 18 plus 6, or 24 plus 3 pi. It's asking you to round it to the nearest, nearest tenth. So it might take a second. I'm going to bring the calculator out. Just waiting for this calculator to come up. So you're going to use the pi button. You're not using 3.14. That should be done. That should never be used anymore, 3.14. Just use the pi button. So let's see. Okay. So I'm going to clear this out. I'm going to go back to my home screen, which is where I am. So the idea was we had the straightaways of 9 plus 6 plus 9 plus 3, half the circle, pi. And this becomes our final answer. 33.42, nearest tenth then becomes 33.4. So this answer then becomes 33.4 feet. That's how much fencing she's going to need. Okay, find the area of the shaded region. Well, we've got a big circle and we've got a small circle. Hopefully you realize that if we can find the area of both circles but subtract them, if you take the small away from the big, you should have your final shaded area. So essentially what we need to do is the area of the big circle minus the area of the small circle. Knowing that the area of the big circle is pi r squared, I know that the big circle is pi 4 squared, which is just 16 pi. The area of the small circle is pi r squared, but the small circle has radius of 3, and that becomes 9 pi. Again, I think that should be pretty clear, right? These circles are concentric. They have the same center. That becomes the radius of your big circle. This becomes the radius of your small circle, okay? So what ends up happening is the area of the shaded region, so the area of shaded region equals 16 pi minus 9 pi, which is just 7 pi. This would become 7 pi centimeters squared. Now, they didn't tell us to round anything. If they don't tell you to round it, then you're leaving it as an exact answer. For those of you that do round it, which again, we didn't tell you to, so you're not supposed to, but if we asked you to round this thing, your calculator, you type in 7 pi, and what ends up coming out is 21.99 or 22.07. centimeters squared. That's the rounded version, but again, it didn't say to round. You shouldn't be doing it. Miss Brown plans to carpet part of her living room. The living room floor is a square, which is 20 by 20. So this is also going to be 20. She wants to carpet the quarter circle as shown below. So find to the nearest square foot which part will remain uncarpeted. Well, hopefully you realize the part that's not carpeted is going to be this kind of triangular looking region. It's not a triangle though, okay? So to figure out what's not carpeted, you're going to find out what the whole floor plan is going to be. You're going to find out what the quarter of the circle is going to be, and then you're going to subtract again. So the idea is if we know the area of the square and we subtract from it the area, now they're telling you it's a quarter circle, minus the area of a quarter of your circle, that's going to be the area that's not carpeted. Okay, so let's break this down to a couple pieces. Well, the area of a square is base times height, which is 20 times 20, which is 400. The area of a quarter circle becomes pi r squared divided by 4. Now remember, you kind of sort of have to visualize this, and maybe I'll go with a highlighter, but you got to have to kind of realize that if you're dealing with a quarter of the circle, the radius of the circle is in fact just this 20. Okay, so what that means here is it becomes pi 20 squared divided by 4, which becomes 400 pi divided by 4, which is just 100 pi. If I now plug all that stuff into my formula, I'm basically saying, okay, the area of my square is 400. The area of my circle, quarter circle, is 100 pi. So mathematically, what we are doing, I'm going to raise this up a little bit, is we're finding that we need to say the uncarpeted region is area of square minus area of carpet. That would be the exact answer. Oh, it says to the nearest square foot. Actually, here's where we're going on the calculator. So this is going to be, and you can write equals, I'm putting approximate, but we're looking for 400. We're going to subtract from that the carpet, 100 pi button. Round this to the nearest foot, square foot. 85.8 should become 86. So the answer here is going to be 86 feet squared, not carpeted. All right, one more to go, I believe. And let's find it. Alrighty. A designer created the logo shown below. The logo consists of a square and 4 quarter circles of equal size. Express in terms of pi the exact area in square inches of the shaded region. So there's no rounding here. You're leaving pi in your answer. The fact that you've got 4 quarter circles, that equals 1 full circle, right? So 4 quarters equals 1 full circle. So what we're going to have to do to figure out what's shaded is kind of what we've been doing on some of the other ones. If we can find out the area of the square minus the area of the circle, one whole circle, that's going to end up equaling the area of what's shaded. So let's take this piece by piece. The area of the square is base times height. Well, all the way across should be 6, which means all the way down should be 6. So we're looking for 6 times 6, which is 36. The area of your circle is pi r squared. Hopefully you realize that this part right here must be your radius, right? If I were to kind of complete that circle. So this becomes pi 3 squared, which is 9 pi. It doesn't want you to round anything, right? So in terms of what we need to do, the area of the shaded equals square minus circle, and that whole thing is inches squared. Okay, so that's it. So you need to just kind of be careful. Do they want area? Do they want perimeter? Do I round my answers? Do I not round my answers? So that should be good for the homework.